Alright, so this video is for my I'm sorry, Algebra 2 from CVCC. We have a Chapter 8 test on Monday and Tuesday over logs and exponents, and this is a sections 8.5, 8.6 review for that test. Remember, 8.1, 8.4 are in a separate video, so I would watch both. Alright, so we have a couple basic problems from each section to do, and you should be good for the test. Now, first we'll start with some of these expanding and condensing problems. These ones we're going to expand. So we're going to take these logs and make them bigger using those three properties: the product, quotient, and power properties. So if we tried to expand A, I'm going to put A right here because it might go across the screen. Well, we have a couple things going on. That is a product, and that is a power. So the first thing I'm going to do is I'm going to use the product property and split these two things up, 64 and x squared, using addition. Log base 8 of 64 plus log base 8 of x squared. So that was the product property, so that's where the plus sign comes in. And now we have a power here. So that power is going to come down in front. Log base 8 of 64 plus 2, I'm sorry. So the power comes down in front, plus 2 log base 8 of x. And that would be a good final answer. Now remember, you should check for bonus on the test. Log base 8 of 64. This is 8 to what power? And I just put it there. Gives you 64. Well, 8 squared gives you 64. So you could also make this entire thing just the 2. So it could be 2 plus 2 log base 8 of x. Either way, you get the right answer. The second one, let's expand this. I see a couple things. First of all, I see this radical. That's going to be a power, and that's what I'm going to do first. Then I see 3 times x. I see a product inside there, and then I see a division sign. That is a quotient. So all three rules are involved here. So the first thing I'm going to do is I'm going to make that power, the fourth root, I'm going to make that the power. So that's natural log of 3x. Now since the 3 and the x are inside the radical, that whole thing is raised to the fourth power. And that's all over y. So now I will use the quotient property first. And I will break this up using subtraction. The natural log of 3x to the 1/4 minus the natural log of y. And this was the quotient property. Then I'm going to use the power property and bring that 1/4 in front. 1/4 natural log of 3x minus natural log of y. So I just use the power property. And then I need to break up this log using the product property. Now, since the 1/4 is in front of this log, both the 3 and the x need the 1/4. So notice what I'll do. 1/4, and I'll put it in parentheses. And when I expand this natural log of 3x, natural log of 3 plus natural log of x, so that both get the 1/4 power. And then the minus natural log hangs outside. So this was the product property. And this is a good answer. Okay? If you want to also, you could distribute the 1/4. So you'd have a 1/4 natural log of 3 plus 1/4 natural log of x minus the natural log of y. And that would also be a good answer. But either one is good. And that's how we expand, using the three properties. Okay, so here's going to be our two condensing problems. So condensing means we're going to take all those logs and make them into one. So let's see. These numbers in front, the 7, the 5, the 3, are all going to become powers. Okay? So first I will rewrite this as the log base 4 of 2 to the 7th plus log base 4 of x to the 5th plus log base 4 of y to the 3rd. So I just used the power property and brought all those to powers. So now what I'm going to do, now let's use the product property and or the quotient property. Now, when you see a plus sign, that means that that item goes in the numerator. Okay? If you see a minus sign, that means it's going to drop to the denominator. So it's all going to be log base 4. Now, 2 to the 7th. If you multiply out 2 to the 7th, you get 128. So here's the 128. So 2 to the 7th equals 128. Okay? So I'm going to make that 128, and it's in the numerator because it's a plus sign. Then there's a plus in front of the x to the 5th. It's in the numerator with the 128. And then there's a plus sign in front of the y to the 3rd. It's in the numerator with the 128 and the x to the 5th. And this is the condensed log. There you go. One log. Now the next one. I see a 1/2 in front of a log. That's a power. So using the power property, log base 3 of y to the 1/2. There is no number in front of this log, so it's just log base 3 of 2. So I just used a power property. And now, if it has a plus sign, it goes up top. If it has a minus sign, it goes on the bottom. Log base 3 of y to the 1/2 is up top. And then the 2 has a minus sign over 2. And this is the final answer. That's using the quotient property. The minus makes you go to the bottom. You could also make this 1/2 power into a radical. Radical 2, or the square root of y. Sorry, the square root of y over 2. This could also be the answer. Either one I will accept. And that's how we condense. That's how we bring many logs into one. Okay, next one, it's going to ask you to evaluate. And this log says log base 6 of 81. This is a log that we can't do in our calculator the way it's written. However, we can use that change of base formula. Remember, we're going to take the quotient of two logs, and the base goes on bottom. So we're going to take log of 81 over log of 6. You could also take the natural log of 81 over the natural log of 6. It doesn't matter which base you choose, but these are the two bases that we can plug in our calculator. Now, I would also suggest that you put the parentheses here on your paper because your calculator is going to open them up, and you got to make sure you shut them. So, if you use your calculator, the natural log of 81, or log of 81, divided by log of 6, and I get 2.45. And again, if you think about it, right, that's the exponent of 2. So if you check, that's exponent of 6. So if you check 6 to the 2.45, my calculator spits out 6 raised to the 2.45, 80.6. And that is very close to 81. So you know that you've done it right. That is the exponent that I raised. 6/2 to get 81. And we should all know that when you evaluate a log, the answer is the exponent. Okay, so that's section 8.5. Let's go on to some solvings. Okay, so we'll go through a problem step by step. And again, we'll ask ourselves the main questions that we need to ask when we see a solved problem. The first question is, are we dealing with exponents or logs? And we should say these are exponents. One side or both sides? Both sides. So this is that like bases case. We need to make 25 and 125 become the same number. Well, we can, because 25 is 5 squared, and 125 is 5 cubed. And there's our same number, 5 and 5. Now, I don't want these parentheses, so I'm going to use the power of a power rule, and I'm going to multiply the 2 times the x minus 1 and the 3 and the 4x. So I get 5 to the 2x minus 2 power equals 5 to the 12x. And now, since these 5's are the same, cross them off. We don't need them anymore, because if the bases are the same, then the exponents must be the same. 2x minus 2 must equal 12x. And we solve. Let's subtract 2x from both sides. Negative 2 equals 10x, and let's divide by 10. And I get x equals negative 0.2, even. And because this was an exponent problem, I am done. No check necessary. So this was an exponent, both sides. Okay, so here's the next one. 5 times e to the 3x plus 2 equals 17. So again, we go through our checklist. Is it exponents or logs? It's exponents. One side or both sides? This time it's only one side. So I need to identify the base and the exponent, e to the 3x. Get that alone. Subtract 2. 5e to the 3x equals 15, and divide by 5. E to the 3x equals 3. Now, the rule is, if you start with exponents, you must use a log to answer the question. So what's going to happen is 3x is going to come down. The exponent comes down. We need that to happen so I can work with it. And we need to take a log of the base of the exponent. Well, that's log base e of the number that's left over, 3. Well, we don't write log base e. That's the natural log of 3. So 3x equals the natural log of 3. And maybe I'll do that in a different color, sorry. We don't write the log base e, right? We write that as natural log of 3. And now to get x by itself, I'm going to divide by 3. So my answer is going to be the natural log of 3 divided by 3. And I'll do that in the calculator real quick. The natural log of 3 divided by 3. And we get 0.366. There was no need to check because this was an exponent problem. X can be anything. So there is my final answer. So there are some exponent problems, okay? And again, one side or both side, how you handle them is a little bit different. Okay, so again, here's another solve problem. So I ask myself, is this logs or exponents? And I say this is logs. Is it one side or both side? Both sides. So now, notice there's one on this side and one on that side. They're both log base 5, both log base 5. You can just cross the logs off. They're gone. And what is inside the log, 2x plus 15, must be equal to what's inside the other log, 3x. Right? That's how these things would be how they would be equal. If the logs and the bases are the same, then what's inside the log must also be the same. And I'll combine my x's by subtracting 2x from both sides. And that's 15 is x. Now, can I circle my answer? Not yet, because I have to check. You always have to check when it comes to log problems. And the only thing you have to check is to make sure that, remember, whatever that question mark is, that question mark better be greater than 0. Remember the picture we drew, the log graph has an asymptote at 0. So whatever's inside there must be greater than 0. So we just check by plugging in. Now I have to do it to both sides. Log base 5 of 2 times 15 plus 15. That's going to be 30 and 45. That's log base 5 of 45. So that checks out good. And log base 5 of 3 times 15. That's log base 5 of 45. And that checks out. Both positive. Life is good. Here is my answer. 15. So that's if you have logs on both sides. Okay, so here's our next problem. 2 times the log base 2 of x plus 5 equals 11. And first thing I do, I'll ask myself, is it logs or exponents? This is logs. Both sides are one side. This is a one-side case. So now we have to identify what the log is. Now do not be tricked because there are no parentheses. This log is simply log base 2 of x. That's all it is. Okay? So this 5 and 2 better be gone. Okay, subtract 5. 2 log base 2 of x equals 6. And let's divide by 2 on both sides. So we get log base 2 of x equals 3. And now, when there's only one log, you must use exponents to solve this problem. This x, we want it to come out of the log, so it does. And over here is the exponential. Well, the base of the log is the base of the exponent, and the answer to a log is an exponent, so that 3 is the exponent. And x is 2 to the third, and 2 to the third is 8. Now, we are not done yet. We need to check. We need to check to make sure log base 2 of x stays positive. 8 is x. That is positive. Life is good. So don't be confused up here. I'm gonna draw something in at the very end. Don't be confused. Parentheses are very important. This x plus 5 now belongs to the log. But without parentheses, only the x belongs to the log. So don't be confused. Okay, here's our last solve problem. It says log of 5x plus log of x minus 1, notice the parentheses, equals 2. So I'll ask myself, do we have logs or exponentials? And we say we have logs. Both sides are one side. Now, the equal sign is here, so these logs are on one side only. But there are two. Well, you must condense first. Two logs, we must condense. So this plus sign means the product property. We can make this log of 5x times x minus 1. And I'm going to put that in a bracket. So now I'm going to do two things in the next step. The first one is I'm going to distribute this and bring it down. So when I distribute it, I get 5x squared minus 5x. And it's going to come out of the log, so I don't need to write the log. And now, to make the log disappear, we're going to rewrite it in exponential form. Remember, if you have one log, you must use an exponent. Now, this log has no base, so it is a 10. So the exponent on the right side and the base is 10 the base, and the 2, the one by itself, is the exponent squared. So this is 5x squared minus 5x equals 100. And now we have x squareds, x's, and numbers. Why don't we move everything to one side? So we get 5x squared minus 5x minus 100 equals 0. That becomes 0. And now this is a quadratic formula, or a quadratic. So maybe we can factor, maybe use quadratic formula. Now I look at that a value, that 5, and I say, I'm scared of you. Right? This a is no good. But 5, 100. Guess what we can do with everything? Divide everything by 5. X squared minus x. And 100 divided by 5 is 20. And 0 divided by 5 is 0. And now, maybe you can handle the number 20. I think I know the factors of 20 pretty well, right? 1, 20, 2, and 10, 4, and 5. And I need a 1 in the middle. Now, when you do your parentheses, that symbol right there, minus 20, the C, means different signs. X squared is x and x. And now, I need a 20. And I need a 1. Well, that's 4 and 5. The 1 is negative. This is a negative 1 right there. So make the 5 a negative and the 4 a positive. And I'm going to carry this problem up here. So now, this equation set equal to 0. So set each of those parentheses equal to 0 and solve. And we get two answers. Subtract 4, add 5. And now you're not done until you check. You got to check to make sure that these numbers keep the logs positive. So let's check negative 4. Log of 5 times negative 4. Uh-oh. That's going to give you a negative number. That doesn't work. Cross off the negative 4. Doesn't work. Now let's try the positive 5. Log of 5 times 5. That's going to work. Log of 5 minus 1 is 4. That's going to work. X equals 5 is a good answer. And these are the hardest type of problem you'll see for these solving problems, where you have to condense first. So be aware, if there's two logs on one side, you always must condense first. Okay, here are the last two problems. We're going to get into our compound interest problems, and this time we're going to be looking for time, okay? So you deposit $2,000 in an account that pays 1.5% interest. Let's do A. How long will it take for the balance to reach $2,500 if compounded monthly? Well, when I see monthly, I know I have to use this formula, the one with n's, right? A equals P times 1 plus R over N, all raised to the NT power. And they tell me what the A is. The A they want is $2,500. They want that to be the balance. You start with 2,000. The rate is 1.5%, which is 0.015, right? Do the decimal two places to the left. N is the number of times compounded. Well, it's monthly, so that means it's 12. N is again 12, and then T is what I'm looking for, right? T, that's the question. So, first thing, let's divide by 2,000, right? I need to get this right here this alone. So divide by 2,000. And when you do 2,500 divided by 2,000, it should be something nice. 1.25. There's this number. And then figure out what this number is. 1 plus 0.015 divided by 12. 1 plus... it comes out nice. 1.00125. And that's nice when it does. If it doesn't, round to like 6 or 7 decimals. Just don't round close at the beginning, okay? But you can round. And now you want the exponent to come down. Well, to bring the exponent down, this is an exponential equation. You must use logs. So the 12t comes down. And over here, you're going to get a log. The base of the log is the base of your 12t. Well, that's 1.00125. And then the other number goes in the big spot. So now to eventually solve for t, you'd have to divide by 12. Okay? So what does this have? What's this become? Well, t equals this right there, the top. I'm going to use the yellow, the top. This needs to be the change of base formula. Base on bottom, log of 1.25 over log of 1.00125. That's the top. And that's all over 12. Do the top first. Do it piece by piece. So if we do log of 1.25 divided by log of 1.00125, I got like 178. So this top is like 178.6. Okay, don't round. Now divide that by 12. And there we go. The time that it takes for this account to get $500 more is going to be 14.9 years. So almost 15 years. So there's part A. Okay, part B coming. Okay, so now we're going to move on to part B. Part B says how long will it take for the balance to double if compounded continuously. So again, we're still looking for T. They still have the same amount that we start with, 2,000, and it still pays 1.5% interest. Now we want to double, and it's compounded continuously. When you see continuously, you need to think of a PERT. The balance, now they want to take the original amount and double it. Well, the original amount was 2,000. To double means 2 times 2,000. Well, that's 4,000. The original amount was 2,000. E to the R is the interest rate. Again, move the decimal place correctly. And it's T. This is my exponent and my base. Get rid of the 2,000 by dividing. You'll notice that when you get rid of the 2,000, the number you get over here is a 2. That is significant because guess what? You had to double it. That's where that 2 comes from. It's double the amount. Okay, so now in this situation, I want this T to come down. So bring it down. But now, to get rid of that exponent, to bring that down, you have to use log. You have to use log of this base. Well, log of base E is the natural log. And we take the natural log of 2. To get T all by itself, we divide by 0.015. Make sure you close that parenthesis around the 2. And this problem should be not challenging. Natural log of 2 divided by 0.015. I got 42.2 years. So about 46.2 years. So about 46 years. That's a long time. Okay, small interest rates. All right. So there's your last 2 sections in a nutshell. All right, so happy studying, and we'll see you on Monday. Thanks for watching.